Solve for x given root 2 cos x over 2 plus 1 is equal to 0 from x is 0 to 2 pi. So this one is back into radians. So is positive? Well, we don't know if it's positive or not because we need to rearrange this equation. So what we're going to do is we're going to go and minus 1 on both sides and get root 2 cos x over 2 is equal to negative 1, and then divide both sides by root 2. You get cos x over 2 is equal to negative 1 over root 2. So it's a negative. So cos is negative in which quadrants? The second and third. The base angle, or using your exact values triangle, the only side that has the root 2 on it is the pi on 4 side, so it's definitely going to be pi on 4. And I've definitely done that correctly. It's pi on 4 because it's got the domain 0 to 2 pi. So now what we need to do is look at the domain. So the domain is 0 to 2 pi, although it says on the inside x over 2, which is the same as 1/2 x. So we need to multiply the domain by that little factor there. So it's going to be 0, x, and pi. So now what we're going to do is we're going to go and say x over 2 is equal to, so we want the only quadrant involved that's in between 0 and pi is the second quadrant. The third quadrant is greater than pi, so all I need to worry about is saying pi minus pi on 4, which is equal to 3 pi on 4. And then I just need to divide both sides by 1/2 or times it both by 2. X is equal to 6 pi on 4, which is equal to 3 pi on 2. And there is my only solution to this equation. So x is equal to 3 pi on 2. Now here's where it gets a little bit more tricky. This is when we've got a horizontal translation, so we have an extra step. Solve for x given 2 cos x minus pi over 6 is equal to 1, where x is between 0 and 2 pi, so we're dealing with radians. So I'm going to divide both sides by 2, and I get cos x minus pi on 6 is equal to 1/2. So it's positive, so therefore it's going to be the first and fourth quadrants. The base angle here to get 1/2 cos on the exact values triangle, that's going to be pi on 3. The domain. Now there's no number in front of that x, so therefore we don't need to affect the domain. So the domain is still 0 x 2 pi, but there is a little minus pi on 6 business that we need to worry about. So we're going to subtract pi on 6 from both domains. So this is going to become 11 pi on 6. So what does that mean visually? So here is 0 and there's negative pi on 6. And there is 0 and there is 11 pi on 6. I'm just going to highlight accordingly that bit there, and then from here all the way through to here. So our reference angle is pi on 3 though. So pi on 3 is of course bigger than pi on 6. So in the fourth quadrant, see how we moved back down to negative pi on 6? Well, negative pi on 3 is actually bigger, so it's outside of the domain, so I don't need to worry about that one. I will need to worry about the pi on 3 in here. I'll need to worry about the pi on 3 in here, so that's going to be at 2 pi minus pi on 3, which will be 5 pi on 3. So we want pi on 3 and we want 5 pi on 3. Now what we're going to do is we're going to add pi on 6 to our two answers here. So pi on 3 becomes 2 pi on 6 plus pi on 6. 5 pi on 3 becomes 10 pi on 6 plus pi on 6. So that becomes 3 pi on 6. This becomes 11 pi on 6. So, and that we can simplify down to pi on 2, 11 pi on 6. So those are our final answers. It is in between the original domain of 0 and 2 pi. And so there we have solved it. And again, you can always go and double check that on your CAS. Solve for x given negative sine 2 brackets x plus pi on 3 equals 1. X is in between 0 and 2 pi. So this will be sine 2x plus pi on 3 is equal to negative 1. Okay, so what values get me a sine of negative 1? Well, let's look at my unit circle, 0, and so if I go to 1, 0, 0, 1, negative 1, 0, 0, negative 1, well that means it's going to be down at this, at the bottom here, that the reference angle being 3 pi on 2. So, first and foremost, it's negative. Now, normally I'd write the quadrants at which we need to get negative answers and things like that, but it's actually not so much a quadrant now, is it? There's only one possible result here, and that's the base angle is 3 pi on 2. Now the domain. So the domain's a little bit trickier here, and it's best to do it in stages. So the original question has asked us to do the values in between 0 and 2 pi. Now, we've also translated and dilated. So let's start with the translation first. So we're adding pi on 3 on both sides. So this will become 2 pi plus pi on 3 is going to make that 7 pi on 3. And then we're also going to double it. It's going to be 2x plus pi on 3. So this is going to become 2 pi on 3, and this is going to be 14 pi on 3. So from a very visual point of view, we'll be starting to look at solutions from 2 pi on 3, which will be, so it's about from here, there's 2 pi on 3, all the way to 14 pi on 3, which is, so just in case that doesn't make sense, it's 2 pi and 14 pi on 3 will be, here's 3 pi, so that goes in, 3 goes into 14 4 times, so we'll have to go around a little bit again, and where's the, go into the green. So there was 4 pi, and that would be 14 pi on 3. So we need to consider, from this point onwards, all of this second circle, and then from here to there. So in those yellow regions, we hit a 3 pi on 2 there, a 3 pi on 2 there, and that's it. So there's only 2 answers that we need to worry about. There's that 3 pi on 2, and this is this 3 pi on 2 there. That's not even a 3 pi on 2. That is a 7 pi on 2. And there we go. I remember how things work. So there's 7 pi on 2. So let's go and get this monstrosity out of the way. So we've got 2x plus pi on 3 is equal to 3 pi on 2 or 7 pi on 2. We are going to go and divide by 2. is 3 pi on 4, 7 pi on 4. And then we're going to minus pi on 3 from both sides. And we get x is equal to, oh goodness gracious, need to get denominators of 12 here, so that's going to be 9 pi on 12, take away 4 pi on 12. This is going to be 21 pi on 12, take away 4 pi on 12. So this is equal to 5 pi on 12, and that will be 17 pi on 12. Yep. And hooray! We are in fact correct. It is 5 pi on 12, 17 pi on 12. Phew!